What if I told you that right now, as you read this, your air conditioner is silently draining money from your wallet? Not because it's broken, not because it's old, but because of one tiny ignored component that costs less than $1 to fix. And what if the reason nobody told you about this fix is because fixing it means you stop calling the repairman, you stop buying new units, and you stop paying those ridiculous energy bills that seem to climb every single summer? Stay with me, because what I'm about to show you has been sitting in plain sight for decades, buried under layers of expensive service contracts and upselling technicians who'd rather sell you a new $3,000 unit than hand you a zero-power 75 solution. Welcome back. If you're new here, this channel is about one thing: the practical knowledge that used to be common sense but somehow got lost, the stuff your grandfather knew, your repairman won't tell you, and the energy companies are definitely not putting in their newsletters. Today, we're talking about air conditioning. Specifically, how one simple electrical fix that costs about $1 can stop your AC from wasting energy permanently. No new unit, no professional visit, no gimmicks. By the end of this video, you're going to know something that I'd bet 99% of homeowners have never heard, even though it's been documented in electrical engineering manuals for over 60 years. Let's get into it. Point number one, your AC doesn't just run, it struggles to start, and that struggle is costing you a fortune every single time. Here's something most people never think about. When your air conditioner kicks on, the compressor motor doesn't just smoothly begin spinning. It lurches. It fights against inertia. And for a split second, it draws an enormous burst of electricity, sometimes 5 to 8 times its normal running current, just to get moving. Electricians call this the startup surge, and it happens every single time your system cycles on. In a hot summer, that could be dozens of times a day. Now here's where it gets interesting. That surge isn't just wasting power in the moment. It's stressing your compressor motor every single cycle, wearing down the windings, heating up the components, and shortening the lifespan of your entire unit. The harder your motor works to start, the hotter it runs, the more electricity it burns, and the sooner it dies. My grandfather was an industrial electrician in the 1950s. He used to say the most dangerous moment in any motor's life is the moment it wakes up. He wasn't being poetic. He was describing exactly what's happening inside your AC unit right now. And the fix? It comes down to one tiny component. But before I tell you exactly what it is, let me show you how to confirm your unit actually has this problem, because almost every unit does. Point number two, the silent symptom your AC is showing you that everyone ignores. Go outside right now, or think back to the last time you heard your AC kick on. Did you notice a slight flicker in your lights? Maybe a brief dimming, just for a fraction of a second? Did you ever notice your breaker feels slightly warm even when nothing seems wrong? Or maybe your electric bill spikes in summer way beyond what the temperature increase should explain? These are not random annoyances. These are symptoms. That light flicker is your entire home's electrical system reacting to the startup surge of your compressor. The power draw is so sudden and so massive that it actually pulls voltage down across your whole house for a fraction of a second. And every single time that happens, energy is being wasted, components are being stressed, and your motor is aging faster than it should. Here's a fact that the big AC manufacturers know very well. A motor that starts hard runs hot, and a motor that runs hot dies young. They know this. And a dead unit means a new sale. So let's just say there isn't a lot of motivation to fix this at the factory level, but you can fix it yourself for about $1. And the component is called a run capacitor. Point number three, what a capacitor is, why yours might be failing, and why it matters more than anything else in your system. A capacitor is a small cylindrical component, usually about the size of a large soup can, sometimes smaller, that sits inside your AC's outdoor unit or air handler. Its job is elegant and simple. It stores electrical charge and then releases it in a precise burst to help the motor start and keep it running efficiently. Think of it like a tiny electrical battery that charges and discharges thousands of times a day. There are typically two types in a standard residential AC system: a start capacitor, which gives the motor that initial kick, and a run capacitor, which supports it throughout the entire cycle. Some units combine both into what's called a dual run capacitor. And here's the critical part. Capacitors degrade. Heat kills them. Every summer, every startup cycle, every hot afternoon in that outdoor unit is slowly draining their capacity. After 5 to 7 years, most capacitors are operating at significantly reduced efficiency, meaning your motor is starting harder, running hotter, and drawing more power than it was designed to. A fully functional capacitor can reduce startup amp draw by a measurable percentage and help your motor maintain optimal running efficiency. A weak or failing capacitor turns your motor into a struggling, sweating, electricity-gulping machine. And here's the remarkable thing. You can buy a replacement capacitor for your specific unit for somewhere between 75 cents and a few dollars if you source it correctly. I'll show you exactly how in just a moment. But first, If this is already saving you money just in understanding alone, do me a favor and hit that subscribe button right now. Because next, I'm going to show you exactly how to test your capacitor, where to get a replacement for almost nothing, and how to install it safely with basic tools. I cover these kinds of real, practical fixes every week. The things that used to be common knowledge before we were all trained to just call a professional for everything. Subscribe so you don't miss the next one. Point number 4, how to safely test your capacitor without any special equipment. Before you spend even $1, let's confirm what you're dealing with. First, and I want to be very clear here, always turn off the power to your AC unit at the breaker before you open anything, not just the thermostat, the breaker. Capacitors store charge and can deliver a serious shock even after the power is off. So after you open the unit, use a screwdriver with an insulated handle to short across the capacitor terminals, touching both posts with the shaft of the screwdriver to safely discharge it. Do this every single time without exception. Now, visual inspection first. Look at the capacitor. A healthy capacitor is a perfect cylinder. A failing capacitor will often show a bulging or dome top. It looks like a slightly inflated can. That dome means internal pressure has built up from heat damage, and that capacitor needs to be replaced immediately. Some will even show brown residue or corrosion around the terminals. If it looks fine visually, the next test is a simple one. If you have a cheap multimeter, they go for about $10 at any hardware store. Set it to capacitance mode, the setting marked with a little capacitor symbol. Touch the probes to the terminals and compare the reading to the microfarad rating printed on the side of the capacitor. If your reading is more than 6% below the rated value, your capacitor is weak and your system is suffering for it. During the Second World War, military engineers working on radar equipment discovered that capacitor degradation was one of the leading causes of equipment failure in the field. Not dramatic battle damage, but quiet, invisible component decay. They developed field replacement protocols specifically because the fix was so cheap and the impact was so significant. 70 years later, the same principle applies to your air conditioner sitting in the summer heat. Point number 5, where to buy a replacement capacitor for almost nothing and how to match it perfectly. This is where most people give up and call the repairman because they don't know how to find the right part. But it's actually very simple. On the side of your existing capacitor, you'll see 2 numbers printed on the label. One is the microfarad rating. It might say something like 45.5 MFD or 55.5 MFD for a dual capacitor. The other is the voltage rating, commonly 370 VAC or 440 VAC. You need to match the microfarad rating exactly. For voltage, you can go higher but never lower. A 440 V capacitor can replace a 370 V, but not the reverse. That's the only rule. Now, where to buy it cheaply? HVAC supply houses, not hardware stores, actual HVAC supply distributors, sell these components at wholesale prices that are a fraction of what a technician charges. A capacitor that an AC repairman bills you $40 to $80 to supply and install often costs between $1 and $3 at an HVAC supply house. You can also find them on large online marketplaces for comparable prices. Search your capacitor's exact MFD and voltage rating and you'll have it in 2 days. My neighbor called an HVAC company last August. They charged him $160, $80 for the capacitor, $80 for labor. The capacitor itself, I looked it up while he was telling me the story, was listed online for $2.19. The replacement takes about 10 minutes if you've never done it before. Point number 6, the actual installation step by step and why it's easier than you think. Take a photo of your old capacitor before disconnecting anything, specifically the wires and which terminal they connect to. This is your reference and it takes 2 seconds. The terminals will be labeled, typically HERM for the compressor, fan for the fan motor, and C for common. Disconnect each wire from the old capacitor and connect it to the same terminal on the new one. That's the entire job. The capacitor usually mounts in a simple bracket and is held by a single metal strap. Loosen it, swap the component, reconnect the wires using the photo you took. Discharge the new capacitor briefly before powering up just as a precaution. Close the unit, restore power at the breaker, and run your system. The difference in some cases is immediately noticeable. The system starts smoother, the startup sound is cleaner, and over the coming weeks, your energy consumption drops measurably because your motor is finally getting the electrical support it was designed to have. Some homeowners report a 5 to 15% reduction in AC-related electricity costs after a capacitor replacement, not because the hack is magic, but because a properly supported motor simply does not have to work as hard. Point number 7, the bonus fix that multiplies the effect, and almost nobody does this. While you're in there, take 30 seconds to look at something else. Find the contactor. It's the electromagnetic switch that controls power flow to the compressor, and it looks like a small rectangular relay with 2 large terminals at the top and bottom. Look at the contact points. the small metal pads that press together when the relay closes. If you see pitting, burning, or black carbon scoring on those contact points, your contactor is partially failing. A damaged contactor causes the same startup surge problem from a different angle. Instead of a clean, full power connection, a pitted contactor creates resistance and heat right at the moment of startup. A replacement contactor costs about $8 to $12 and installs the same way. Photo first, disconnect, reconnect, done. Pairing a fresh capacitor with a clean contactor is the complete 1-2 fix that HVAC professionals charge $200 or more to perform. And now we get to the tip I mentioned at the beginning. The one that stops the energy waste permanently, the one that's been buried so effectively that even people who work in HVAC often don't mention it to homeowners. Ready? It's called a hard start kit, also known as a start assist device, and it is the single most impactful dollar level upgrade you can make to a standard residential air conditioning system. Here's the situation. A standard run capacitor helps your motor, but it's a passive component. It can only give what it stores. A hard start kit adds an additional capacitor and a positive temperature coefficient relay specifically engineered to give the compressor motor a massive, precisely timed boost during the startup phase, and then automatically disconnect the moment the motor reaches running speed. The result is dramatically reduced startup amp draw, significantly less heat stress on the compressor windings, faster startup times, and measurably lower energy consumption over the life of the unit. Engineers who designed early commercial refrigeration systems in the 1960s used this approach to extend compressor life in remote installations where replacement was expensive and difficult. The technology was well understood. It simply never made its way into consumer HVAC products as a standard feature, because a longer-lasting compressor is not in the manufacturer's commercial interest. A hard start kit for a standard residential AC unit costs between $5 and $20 depending on the amperage rating you need, and you match it the same way you match the capacitor by finding the right range for your compressor's rated amp draw, which is printed on the unit's data plate. Installation adds 2 wires to the compressor terminal. That's it. You can do it in under 15 minutes with a capacitor and contactor replacement as a complete tune-up package that costs you under $25 total for parts, versus the $300 to $500 a full service call runs. The compressor in your AC system is the most expensive single component, often $1,200 to $2,000 to replace. A hard start kit reduces the stress on that component every single day. This is not a marginal fix. For a system that's more than 5 years old, this is potentially the difference between getting another 10 years out of your unit and replacing it in 3. So let's bring this home. Your air conditioner has been working harder than it needs to, starting harder than it should, drawing more power than necessary, and aging faster than designed, not because of bad luck, but because of 1 or 2 small, cheap, replaceable electrical components that nobody told you to check. A capacitor, a contactor, and a hard start kit. Together, under $25. Together, potentially thousands of dollars in savings over the next decade. The information in this video is not secret in an academic sense. It's in every HVAC textbook, every electrical engineering manual, every professional certification course. It's just never been handed to the homeowner in plain language, because the homeowner calling a professional is a business model, and an informed homeowner is a disruption to that model. You are now that disruption. If you got value out of this, please subscribe. We put out a new video every week on exactly this kind of practical, buried, genuinely useful knowledge. Drop a comment below and tell me how old your AC unit is. I'll tell you right there in the comments which of these fixes to prioritize first. And if you want to go deeper, click right here for the next video where I show you the 5 other components in your home's electrical system that are quietly draining power around the clock. Same approach, cheap fix, permanent solution, information they'd rather you didn't have. See you in the next one.